Hello everybody, welcome back. This is the video that supports the Pre-Calc 11 Graphing Polynomials booklet that I've got out right here, this one. And it's an extension of stuff that we already know how to do. Right? We already know how to graph an equation like this, that you find your x-intercept, so -3, -1, and +2, right? We find the values that make our brackets equal to 0, and those are our x-intercepts. And then your y-intercept, you let x equal 0, so 3, and then times 1, times -2 is -6. So like that, and we draw our little graph. Now we've done this before several times, and that's nothing new. So what's new is the fact that we're going to be taking an unfactored polynomial, trinomial like this, and factoring it out into its brackets. And it involves details that you already know how to do because we had talked about them before. So you know how to manage long division or synthetic division, which I'll review in this lesson, and then it also deals with the factor theorem. So this video will just deal with those details. And if you're strong with these details, or you just want a quick review, then that's fine. But if you want to skip the video and go straight to the actual work, where we go from here to there, then you might want to just go to the next video. Okay, so let's have a look at long division, synthetic division, and see how that plays out. Okay, so we've done this before in class. This happened right before spring break almost. And so I want to think about how to divide this binomial x plus 2 into this big polynomial, which we call p of x. And so if you recall the process, we have to think about what values make this x. What do we need to multiply this x by right here in order to get that first term on our in our division? So what times is by x to get you x cubed? Right, you can think of it like this. What times by x to get you x cubed? Right, you think of it like that. So right, this is x to the 1. So I need 2 more x's. So this is going to be x squared. Right, that's what I need. So I put x squared at the top. Right, what times is by x to get us x cubed? And you're like, okay, I kind of remember that. Remember, we take this, the guy on the top, and we multiply it by our divisor. Sorry, I dropped my pen here. Come on. We multiply this by our divisor here. So that's a little bit of front door bomber in. And I'm left with, well, x squared times x is x cubed, and x squared times 2 is plus 2x. And then I minus, right? I minus that from that, so x cubed minus x cubed is 0 x cubed, right? That's what we want to have happen. In each step along the way, we want to have zeros all the way down. And so we want to figure out how this chain of events happens. What is the number that I need here to eventually to get me to be a 0 there? And that's really the point of the whole process. So, okay, we've got our 0. 6 minus 2, right, that gets you to 4, so 4, this is a little squared over there, 4x squared, and then I drop the next number as in regular long division, and I proceed to go through the same process again. Only this time, instead of canceling out an x cubed, I want to cancel out a 4x squared. So what times is by x to get me 4x squared, right? What times is by x to get you 4x squared. Nope. What times by x to get you 4x squared? Well, you know, the pattern is just one less x variable. So this is just going to be plus 4x. So 4x, I don't need to show the plus. Multiply it by the divisor. Got some front door bomber in here. 4x times x is 4x squared. Notice that these will cancel out. 4x times 2 is plus 8x. I subtract, as I did up here, and I get 0x squared, and then 4x times 2, sorry, 1 minus 8. Careful here, right? You got a negative minusing a positive, so you know that's going to be negative 9x. Okay, because of the negative, I'm starting at negative 1. I'm minusing positive 8, so really negative 1 minus 8. That's negative 9. Okay, careful there. Some people make mistakes on that kind of stuff. Okay, and then we just do the same thing for the last one. So minus 3. I don't really need to show the 0 here. Right? And I go through the same process again. I say what times is by x to get you negative 9x. So negative 9. Okay, maybe I'll write that negative because I got smudged a little bit. Okay, so negative 9. Again, negative 9 times the divisor, x plus 2. Okay, so what's that? Negative 9x, those will cancel. And then what's that? Minus 18. So that'll get you 0x, which I don't need to show. And then negative 3 minus negative 18. Remember what happens when I get a double minus? Adds. So this is really like negative 3 plus 18, because this minus and that minus. So that's really plus 15. And this 15, I don't need to show the plus, but this 15, that's your remainder. Okay, so long division is a bit of a pain in the butt, and I'll show you the synthetic division so that you know how to do that top secret method. Synthetics is not really part of your curriculum, but I'll allow you to use it because it's a nice handy tool, and you can use that to your advantage if you wish. Okay, so I'll do the same question. We know what the answer is here. I might want you to scroll back to this, or I'll keep it in mind as we go through the synthetic division. Okay, so here's our answer up here, right? I left that up and I just erased the bottom stuff. And when we set up synthetic division, you need 3 lines, right? 2 with the big L shape, and then the one little line underneath it. And you start off on the outside by taking the opposite of this number here, so that's plus 2, make it a negative 2. And you take all the coefficients on your big polynomial up here, right? And of course, if you don't see a coefficient, it's a coefficient of 1. So I have my coefficients of 1, 6, negative 1, and negative 3. And then we plug in a little 0 here to get us started. So the process is that you add going down. So you add that way. You start off, so 1 plus 0 is 1. Right? And then with that number, you multiply it by the number that you used here, the opposite of that number, right? So negative 2 times 1, and that goes up in that slot there, so that's negative 2. Okay, and then repeat the process. Down, add going down, so 6 plus negative 2 is 4, right? Negative 2 over here times 4 is negative 8. Add going down. That's negative 9. Okay, again multiply. So that's plus 8. Sorry, negative 18. Sorry, plus 18. Okay, negative times negative. So plus 18, and then negative 3 plus 18 is plus 15. That was our remainder. Boom. Right there. Okay, so that's a nice quick way to check your remainder. And also, these numbers here, 1, 4, and negative 9, they are the coefficients for up here. 1, 4, and negative 9. Okay, so you can use this method approach if you like. I'm not going to, I can't police it, and I wouldn't police it anyways. The only time I would have asked you to know the proper way is if I gave you a specific question to show me how to do regular long division. But that's really it's up to you to exercise how you feel at ease with whichever system you like. Okay, so I also asked you to write out this little statement. So this here is our polynomial, p of x, right? We can write it out x cubed plus 6x squared minus 1x minus 3. That's this guy right here. We call that p of x. Okay, and it's equal to my divisor, x plus 2, times my dividend, x squared plus 4x minus 9, and then with our remainder, so plus 15 on the outside. And I asked you guys last time when we did this way before at spring break to write out your answers like this, because there's a value in knowing how this or what this means. And so I'll have a look at another example, and I'll talk a little bit about the remainder theorem and the factor theorem. Okay. Okay, so if you recall, right, our original dividing question was this, and we had our remainder here equal to 15. So the remainder theorem, we did this before spring break as well, says that if p of x, so p of x is this guy in here, our polynomial, that's what p stands for, is divided by a binomial with in this shape, so 2 is equal to h, right, because that's x plus 2, and then so that's where that is. Then the p of negative h, so I'm going to sub in the negative of that value into the x values of my polynomial. That's just function notation. And that will equal my remainder. And there's my remainder down there, so let's see if this is indeed true. Okay, so I sub in minus 2 into my polynomial, my x values of my polynomial over here, right? So the opposite of this number here into all the x values. And this is what I get when I sub them in, and I just have to calculate that out. So be careful about your bed mass when you do that. Okay, and then when I calculate it out, remember when you got minus 2 squared, you got to square it first, so it becomes positive 4. 6 times 4 is 12. That's where people make mistakes on that. And then if you just add all that up, you get 15, which is what our remainder is. So there's another way to calculate the remainder very quickly. You can have synthetic division, or you have this remainder theorem. And we're going to be using this remainder theorem to help us find factors. So a factor happens when the remainder is equal to 0. And you can test to see if you're going to get a remainder equal to 0 very quickly by plugging things into your remainder theorem. So let's have a look at a new set of examples, and we'll talk a little bit about factors. So here's a simple question. Is 2 a factor of 10? Yes, 2 can be divided evenly into 10. So let's just go through the long division and see what that looks like. There's good old-fashioned long division for a very simple question, but the result in the process has some value. So let's just have a look. Right, it's a factor because we have a remainder of 0. We have no anything else. That means that 2 divides evenly into 10. Right, 2 divided by 10 is equal to 5 with no remainder. If this was an 11, say, right, then 11 minus 10 would be equal to 1, and we can't say that 2 is a factor of 11 because it has a remainder. So what's important is that all factors have a remainder of 0. And we know how to test for factors. We have two ways. We have synthetic division, and we have the little remainder theorem. So if you're testing and you come up with something that has a remainder equal to 0, pow, you've already solved the factor. And let's see why that's important. Okay, so if you scroll all the way back to the beginning of the video, I basically said, okay, well, we can graph this, but we can't graph that. And so our job is to factor it. So these are the factors, these 3 brackets are the factors of this polynomial. They factor, right? So, okay, let's test to see what that looks like when we do the long division, or the synthetic division at least, make it quicker. Okay, so this is what I want to do. I want to divide this polynomial by that factor. Now we should get a remainder of 0, and you could go do all the long division, or we can just do our synthetic division. So I'll complete the synthetic division and we'll see what we get. Okay, so there's the synthetic division. This is my work that I get. I mean, you may want to pause the video just to follow the thinking through. Okay, and so I can say that my original polynomial, this guy here, So this guy here is the same as or equal to x, sorry, that should be x plus 3. There we go. X plus 3, this guy, right, that's one of my factors. And the other part that's left over, well, that's going to be 1x squared minus 1x plus 2. Right, so that's that. And my remainder is 0. So that lets me know that this x plus 3 is a factor because I have no remainder. I don't have to show that plus 0, right? It's just there for illustrative purposes, but I have this. So all I'm left with doing is factoring a trinomial. I mean, we've been factoring trinomials since grade 9. So I have one of them. I got the x plus 3. That's that guy there. And this guy here should be able to break down nice and quick and easily factoring of those two binomials. So let's finish that off. Well, I did a tiny little cheeky cheat here. See if you guys can catch it. Anyway, so here's our polynomial. Bada bing, bada boom. Here's the original. There's its factored. We know it has a remainder of 0. And I just factored this last trinomial into its two binomials like that. Just, you know, regular reverse FOIL type job. So that's the main process. The trick comes in figuring out what to test. And that has to do with our very last digit. It doesn't have an x beside it. And so if it doesn't have a variable, it doesn't vary, then we call it a constant. So the negative 6 is your constant. And that informs us of the possible situations that we can work with. So I'm going to pause it here, and I'm going to end our video, and we'll talk about the whole shebang. Next video will probably be a little shorter as we get through these details. All right, take care, everybody.